Hi guys, welcome back to Take Samadhan. So we have started a new series of machine learning and hope you have liked my video about what is machine learning and the basic four algorithms in machine learning, how they are categorized, what their difference is. So today we would move forward with supervised learning. As we discussed in the previous video, that in supervised learning we deal with label data. So we provide input as well as label output, and decisions are made upon that. So now this supervised learning definitely has some algorithms for namingly you can see here linear regression and logistic regression, which are basic supervised learning algorithm we can say. And there are many more such algorithms present for supervised as well as for unsupervised learning. So today we will understand that what is linear regression, why is it used, and what is logistic regression, why it is used. So supervised learning is basically classified into two main types. One thing to note down here is that supervised learning is classified into two types. Okay, so first is classification, and the second one is regression. So see, machine learning is classified into supervised, unsupervised, semi-supervised, and the reinforcement learning. Furthermore, supervised learning is classified into classification and regression. Now, this classification, this is a predicting category like yes or no, or some binary value 0 1 or true or false. Like for an example, email fraud detection we can think of, like it is spam or not spam. So it is non-continuous discrete value we can say. So it is for discrete value, this classification. For example, spam or not spam. So this is for the discrete value, and definitely regression is for continuous continuous value. Like if you want to predict the price of house prices, as we saw in last example, like house prices if you want to predict, or share prices if you want to predict, then it's for continuous, and this for district like 0 1 spam not spam, and it's for the continuous thing. So linear regression, now definitely it's a regression we are seeing uh, first. So it is for predicting continuous values. Linear regression finds a line that best fits the relationship between input and output. So basically, it's a linear graph uh, going through x-axis, y-axis, and it will going through the center of it. So that's a linear regression works on the plot. The goal is to minimize distance between actual and predicted value. So what does this line means is that if the actual value is suppose 5 and our predicted value is 2, so it the model is not best because it is predicting value which is not even closer to the actual value. So that is what does that definition means, to minimize the distance. So if it predicted as 4.88 or 4.99, it is the best one. Then we got a better accuracy because the distance is furthermore is less now. So this is the mathematical equation for linear regression. So in your colleges, if you are the machine learning uh, subject, then definitely along with your lab work, you need to solve some mathematical problem also. So this is its equation: y is equals to mx plus b. So as you know, y is the output, m is the slope, and b is the intercept for x0, and x is my input now. Now, understanding more about linear regression is that we need to predict what it is, like why we have used these two different kind of regression, why the logistic and why the linear regression. So logistic regression is used in both, in continuous as well as like in classification as well as regression, as well as in unsupervised also we can use it. So furthermore, linear regression is statistical method where we find relationship between dependent and independent variables. Now here, the dependent variable is my output, because you can see here it in equation itself that y is dependent upon my input x. Directly proportional it is, right? So my output is dependent, and my input is independent. Now this is just a linear regression. We have multiple linear regression where there is more than one input. So relationship between a dependent variable and one or more independent variable, it should fit in a straight line. For example, you can understand like you want to predict your exam score based on how many hours you studied. So linear regression draws a straight line that best fit relationship between study time and score. So then that x must be the hours you studied and y must be the predicted score. And this is the slope m, which will tell us how much score increases. So yeah, moving forward, we will understand that linear regression is used for predicting continuous outcomes and like scores or some prizes. If it fits a straight line to the data using least square method. So this least square method is the evaluation method, which will be understood in the course of video. So it works well for simple relationship, but for complex it will struggle because we'll get non-linear patterns. So output is predicted value based on relationship learned. Our output here is the predicted value, but based on relationship it learned between input and output. So this is the same example I took. X is input, which is the size of house, and Y is output, which is the price of house. This is the data we provided for to our model so that it get uh, learning about it. Then we call that linear regression model, which we imported, and I will provide in this video as well how this line we used it here. I have covered this in the Python for Beginners playlist, so please do watch it, guys. Then we fitted that model. Then we predicted our model for 1800 square feet size of house. Now here we haven't provided that data, but by understanding the relationship between the input and output, that is between dependent and one or more independent variable, it will predict the value. And as our goal is to minimize the difference, we can see after running it that yeah, the value is some 3600. So we can see here, like for 1500 it is 30,000, 2000 it is 40,000. So 1800 would definitely lie in between this. So it predicted nearby, and we have just minimized that distance between predicted and original value. So linear regression is for continuous variable. Now moving forward with logistic regression. Now this is the mathematical equation. Is a sigmoid 1 by 1 plus e to the power minus z. Logistic regression is also a statistical method where we predict binary outcomes, as we saw here, binary outcome, as we also 0 or 1. So it is discrete value we predict in logistic regression. Here linear, continuous, and here we will predict discrete value. So you can see here logistic regression. You can read it here itself. Okay. So moving forward, Uh, here there are two possibilities for classes like 0 or 1, yes or no. We are here using a spam detection. So the mail would be either spam or not spam based on one or more independent variables. So that is the input we provide. So we can think logistic regression as decision making process. Now if you want to predict whether an email is spam or not, logistic regression takes the input features like number of links, we can say suspicious word, whatever data you will provide it, it will take it and assigns a probability between 0 and 1. So here itself it is assigning a probability between 0 and 1. Okay. Then if probability is greater than 0.5, suppose it predicts 1 as a spam. So see here we have 1 as a spam. So if my probability comes out 0.5, like greater than 0.5, zero point 0.5 would be my threshold. Then it will predict it as 1 itself and it would go into spam. If my probability is less than 0.5, it will predict 0 and it will go into category of not spam. The logistic part comes from sigmoid function. So you can Google out at and see what is sigmoid or graph would look like. So it's an S. So it will squeeze the output between 0 and 1. We would require 0 and 1. So from a sigmoid, we will get that logistic regression. Why? Because it will squeeze the output. Sigmoid will squeeze the output between 0 and 1. You can see that sigmoid graph. So for this example, if we say that zero point 0.5 is my threshold, if zero point 0.5 is threshold, and if anything greater than zero point 0.5 we got it, then it is spam, less than not spam. The model predict 1 if output probability is greater than zero point 0.5, otherwise 0. So here is a simple example of email detection. We have provided email length and whether it's spam or not spam. So this is my email length. Okay. Now what is this? This is the spam status. Like these two it found that not spam and these three it found that to be spam. We call that model. We fitted it here. Then we predicted for 35 now. We haven't provided it. Now we will just see for the model 35. Now predict for new email of length 35. What we will see, we can see here. So yeah, I will show you once again. See towards the terminal side. What does it predict? 35. So it predicted 35 to be spam. So it predicted 35 as spam because you can see here from this it learned it, the relationship, and it predicted it as spam. So model takes email length as the feature. If the email length exceeds certain threshold based on the training, the model predicted spam. The output will be 1 if predicted as spam, and the output would be 0 if it is not spam. So logistic regression definitely it will predict binary outcome. It uses sigmoid function to produce probability between 0 and 1 and works well for problem like spam detection, some medical diagnostics. For the logistic regression part. So hope you understood that logistic regression is used for classification. It is type of classification, and it is a type of classification. And linear regression it is a type of regression because definitely it predicted binary values and linear predicted continuous. So this both the types are different for the logistic regression as well as the linear regression. So in the next video, we will understood what decision tree is, and one catch is there, decision tree is used in both classification and regression. So that's it. Now you understood how to use linear regression and logistic regression, difference between them. And in the next video, we'll cover decision tree in machine learning, one of the most powerful algorithm we can say. So if you found this helpful, hit like, subscribe, and comment machine learning mastered if you made it at the end.